recording. So let me start the recording. Oh, then also write the organizational things in chat as well, so others can see them. So yeah, basically what is Git about and what the version control is about. Remember, we are changing we want to change the recent version we have in the remote repository. So the remote repository is usually considered as the folder, the main folder from where the key program, the production program, as we can call it, from where it takes the source files, source program, which also some related files needed. And then basically, yeah, what do we need? We as developers, we need to do changes there. We need to make some changes and then to share the changes with others, and then also to promote these changes to the resulting program. Yeah. So this is what we want to achieve, and basically how the version control system works. We have this remote. So basically, what do we need to make changes? So to make the changes, it's obviously we need to have the latest version to work with. So because like if you want to make the changes in the application which has the latest version promoted, I would say maybe some days ago, and then you take the code which was developed. You take the version of the program which was developed, like let's say 2 years ago. Then it's not the best way how to make the changes, right? You don't make the changes in the program which was changed, let's say, some days ago, and you take the version from 2019, and then you make the changes there. Then you push the changes. It's obviously then these changes will result in the conflicts. Because it's obviously then you may have the situation when you are working with the files that were changed lots of time during the last 2 years. So this is why we need to be sure that we are working with the latest files, latest folder, latest repository, what is promoted, what is located in the remote repository. Yeah, of course we use the branches. Yeah, then we can use the branches. Then we can have different development in different branches. But the key idea is that at the end you should have the latest version. This is the first thing. And second thing is you obviously cannot, like, let's say you have one application. Yeah, this application is stored in the remote repository, and then you take the random folder. You create the random folder from somewhere. You create some files or even some folders, and then you want to push these files, these folders to the remote repository. Of course, it's also obvious how it should not work, because the versions, what I said today to one of the students, that the versions are not synchronized. Yeah, so most likely it means that you have the version Git repository located in your remote repository, in remote server, and you simply create, let's say, some new folder. You create basically new Git repository. You don't clone it, you create a new repository, and it's obviously that it won't be synchronized. So if you want to push any changes to the remote repository, you should have at least you should have the cloned repository from the remote server first. You need to clone or have at least the same let's say reference as the remote repository has. That's first. Yeah, so you have Git repository, local Git repository, and then it is the same as, not the same from the content perspective, but at least it is cloned or has the same reference as as the remote repository. So that's the first thing. Yeah, you cannot create, let's say, new Git repository and then push the changes to the remote repository. Yeah, so for example, let's say, so let's go with the examples here. So let me take my repository. So let's say I have my Git remote repository. Yeah, so I have some activities. Here I have the latest commit. I have one branch. Again, at this point, I will not use many branches since we don't need them. And yeah, so let's say what in theory I or other developers can do here. So let's say that again, it's me or any other developer who wants to make some changes there in this folder. So let's say what we should not do. So I go to the any folder. Again, it doesn't matter where do you do the changes, how do you create the files, if it's from Visual Studio or any other ID or from any place you want, it doesn't matter again. Since the files, just basically they are the files and it doesn't matter from where these files come. So then let's let me create a random repository again. This can be the project, this can be solution, like any type of files. So, and then what I don't need to do is I don't need to create the Git repository. So let me go to the command prompt again. You can use any other user interface. It's not important here. So, and then let's say that I initialize Git repository. So at this point I have a Git repository, and even at this point this should not be correct since now these repositories are not synchronized. So if I have any files in the remote repository, if the remote repository is empty, then it doesn't matter since there are no files there. There is nothing to synchronize. However, on the other hand, if I have the files here, so it means that I need to. It's obvious. I need to have them locally than to make any changes there, because at this point we have two different Git repositories which have no relations between each other. Yeah, so then let's say, for example, I want to push the file to the remote repository. So let's run the file here. And yeah, so let's git remote at origin. So so I usually comments. I usually sequence of them. One moment. Just yeah. So git remote at origin. Git remote at origin. Yeah, that's correct. I mean, I usually mix up the sequence of the what. So okay, this is correct now. I need to get the link. I guess then I can use this link. Right. So then I use this link. Yeah. So now I have the link, and let's say that I want to add the file, and then I want to commit the file. Commit. Say that's a random commit. Let it be. And so okay, yeah. So this point goes, and basically what happens here. Let's see. Yeah, at this point you see that the push is rejected. Yeah. So why it is rejected? As I said, because the repositories are not synchronized. We just simply created the random repository somewhere, or on our computer, and now we are trying to push the file to the remote repository. Of course, this is not correct, since again, the repositories are not synchronized. Yeah, so I mean, this repository has absolutely different history, has absolutely different files than your local repository has. Yeah. So please be careful here. So how you can basically solve this issue? So first of all, you can you could clone the remote repository. That would be an option, and another option would be that you do the pull. Yeah. So let's see what happens after pull. Okay. Oh yeah, sorry. Git pull origin. So yeah. Yeah, you see, there are unrelated histories. So what you can do, you can use fetch then. Then git merge. Then moment. One moment. Yeah, so at this point, your Git repository, this repository does have the latest history. Yeah. So yes, then yeah, basically this file is it is not encoded in the history. That's why it does not really like it. It does not really like it. Yeah. So yeah, this is not good. So basically, then the best option I would say would be, of course, there are the ways you can force. Maybe let's do it. That would be force pull. That maybe won't be on practice. This of course won't be the best option, but sometimes. Sometimes I can do. Let's also do git fetch all. Wait, sorry. Git fetch. Yeah. And then let's do the hard reset. Let's try this out. Okay, so let's try now. Moments. Let's try again. Reset. Let's try to pull. I mean, this is not the best way. Okay, yeah. So yeah, they basically doesn't want them to do it. Okay, then one more option would be taking git reset. Again, I do hard reset, then I do the cleanup. Yeah, that would be try run. And then I try to pull the changes again. Yeah, that let's try to then merge. Okay. Yeah. I mean, of course, even at that point, that would be great. Okay, let's try one more time. Okay. Okay, never mind. Then we need to best way would be that we delete this this file then, since it makes us the problems. Yeah, I mean, yeah, the best option would be that we delete this repository. Yeah, so basically the lesson is that do not do it this way. So what you can actually do is, in this case, if you want to use another folder, then the best option would be, I mean, there are some ways how to force this, but I don't think it's worth it. It's worth it. So how we can do, if you want, you can initialize the repository, or you can clone the repository. At this point, it doesn't really matter. But on the other hand, what you can do, as I said, the best option, alternative would be that you, first of all, before you do any changes, before you make any changes, you do the pull operation. So you do the pull operation. Now it should, yeah, so now you can see that you have all the files, and then you can make your own changes. Yeah, so the key point here is, yeah, so I have my random file, and then I can push it to the remote repository. And then I can easily push it to the remote repository, and then it should be fine. Yeah. And it should be here now. So yeah, that's the point. That's the point. Please be careful here and make sure that your repositories are synchronized. Since again, if you just simply, and again, at this point, this is a small example. Yeah, so you just add one file, but sometimes there may be the mistakes where there are more than one file. Yeah, there are a bunch of files there, and then of course. It is possible. You need to do some rebasing. You need to do some maybe unneeded merging, but I mean the easiest would be that you get the latest version, and only after that you do the changes. Yeah. So, do you have any questions about it? Okay, so if no questions, I hope it's clear for you. Just in case you face it in future, let me know that. Okay, so finished with Git components, we'll have a larger session about Git a little bit later in this course. Where we will also talk about the branches, yeah, and similar things. So we will do it later. For now, let me quickly remind you about the method calling. Yeah, so why do we call the methods? Why do we need the methods? Methods help us to make the code reusable. Sometimes, and if the code is reusable, then we make the code, the total code we have in our program, we make it smaller. Yeah, we make it smaller, we make it more readable, more understandable, and also we encapsulate the behavior of the code. Since, again, as I mentioned to you some sessions ago, when we name the methods, we should normally name it in the way that it is understandable for all the developers who use this particular method. What do we expect from this method? Yeah. So that's why when we want to encapsulate some logic, when we want to make some logic reusable, we can create the method. Yeah. So regarding the syntax of the methods, if it's a static method, then we define it as static. If it's instance method, then we don't use static keyword. So, but since we will talk about object-oriented programming quite a bit later, you remember that we can simply use static then. Yeah, so we use static. Before that we can use access modifier if it's public, protected, private, or default, and then it describes the visibility of the method, from what part of code can I call this method, and from where part of code I cannot call it. So yeah, if I call the method only from inside the class, then you can always use private, and that would be enough. If you use multiple classes, then you may need to use most likely public. If you use inheritance, then protected may be needed. So yeah, it's public, and then next point is the returning type. Yeah. So returning type or the void. Again, if it's the void, then we don't need to return anything from the method. Yeah. So let's say we want to return integer. Then the next thing is method name. Remember that we have the naming conventions, and in C# we normally call the methods starting with the uppercase. Yeah. So as main method, same as for all the other methods, we should normally call them, give them a name which should start with uppercase letter. So, and then that would be, let's say, this would be quite some. That would be 2 integers, and then we return some of them. Yeah. So, and then we can get the sum of the numbers. So nothing really special in this case. Yeah. So regarding the calling, as you asked me last time, why do I use this? Yeah, so as I said, this I use for objects. For the class and for the static methods, remember static methods belong to the classes, and the instance methods belong to the objects. So to call the static method, in this case, we can call it this way. Yeah, so I simply provide the name, and then I provide the arguments to the method. And similar as for this keyword, for the static methods, we can use the name of the class instead. Yeah, so something similar what we have for this keyword. Yeah, so again, in such case, there will be no difference if you use name of the class or you don't use. But in some cases, this may be needed. Yeah, for example, you have second class, and then so you have program 2, and then I want to call this particular method from this class, not from this class. Then I use I specify the name of the class, and this is such approach is similar to where we use this keyword. Yeah, so in this keyword, remember we specified the instance of the object which we want to use. If we use this keyword, then it's actually the object uses itself. But same is for the classes. Yeah, we specify which class from which class we want to call the method, and then we specify the name of the class. I usually prefer using the class even if I call from the same class, since for me it makes the code more readable. And more readable since here I specify from what exact class I'm calling the method. Yeah. So just it simply depends on what is better for you, but there are no strict rules for such usage. Yeah, and again we provide the arguments. Yeah, we can provide the arguments, and then remember that sorry, hold on. Then we can provide by value, and we can pass by value, and we can pass by reference. So by default, remember, so this is the property which was not clean at the beginning of our previous course, but then I guess at the end of the course my group did understand this property pretty much well. But yeah, so what's the point? The point here is by default the values are passed by value, and in C# there, and also in C++, there are differences. If you pass the values by value or pass by reference. So as we talked last time, we can also use pointers in C# and C++, but yeah, as I mentioned last time, in C# pointers are almost never used. They are unsafe, and C# tries to stick to so-called, we can say, Java approach, which Java does not have the pointers. Java has the references, same as C#, and basically C# and Java have this property in common that they use references, not pointers. And actually, there are some differences between references and pointers, but I would say the key advantage of them is the same. Yeah, so we basically are dealing not with the corresponding variables, not with the values of these variables, but we are dealing with the actual pointers to the memory. And so we are saying that here we have the address to the memory, and now we pass this address from one place to another, and then we use this address to then access the memory directly and make the changes. So it means that every place which stores the reference, the address of this particular place in the memory, it actually then, yeah, so it means that from every place where you access this memory, then means that if you do some changes, yeah, so do some changes from this particular place in the memory, then it will be reflected in all the places where this reference is stored and where it's moved. So yeah, and so again, what's the difference between pass by reference and pass by value? By default, you have pass by value. It means that when you provide some values from any value from the method calling, then right here the program creates a new variable. It will be the variable A and another variable B, which will be created inside this method and will only be used inside this method. So the scope of life for this particular variable will be this method only. And it means that the method is called, these variables are created, we pass the values from them, so it means that we create the variable A and assign the value 34, so from this particular method call, and then we create the variable D and we initialize it with the value 21, and then we return and get a new value down. So it means that these variables, they are initialized here, but they are not related to anything what we provide from here. So new variables are created and then used. So it simply means that when we, so yeah, at this particular point, that will make sense. And let's say that we, so to make it interesting, we provide the variables, we create the variables here, and then we pass them from here. Yeah. So again, what happens here? Here I passed, yeah, let's run the program and you'll see the results here that these two variables will be summed. So, and then let's also go to the oh, sorry, what are building errors? Of course, I have two main programs, so just to not confuse the application, let's delete the second main. Yeah, because if you have the executable file, then you should normally have only one main method. Okay, let's run, and so we have the result. Yeah, just simple sum. But what is more interesting for me is what are the values of A and B. So then let's do the same with B. Let's show it here. Let's show it here, and yeah, so we display the values. So again, at this point it makes sense. We don't make any changes. But let's say that we want to make some changes. Here. And so what will happen? It will return the sum of new values, of course, since the values are changed here, but initial A and initial B, they stay the same. Yeah, so they are assigned here and the values stay here. So again, what happens at this point? These two variables are created here, they are changed here, and then they are used in return. So, but what will happen if I change and pass values by reference? So what will be the result here? So those of you who are already familiar with with reference, with passing by reference. So the question to you, what will be here? What will you see at the output when we pass the values by reference? At least the value A, we pass it by reference. So question to you, what will be displayed at the result? So you see that we define the first variable as the reference, so pass it by reference, and then we display it here. So anyone has the idea? You can write it in chat if you want. Are you still here? Just I can't hear anything from you.
Well, in case of the reference, in the method it will use this number from 34.
Yeah, but then what will happen? What will happen at the result here? So it will show the sum, then it shows A and B. So in this case, remember that it shows these two variables.
Yes, it shows 2, but in the method, if reference, the same situation.
Not exactly, since what happens here? Basically, so let's run and see the result. Let's run and see the result. Yeah, so you see that B stays the same, but A is changed. So basically, what happens? As I said, when we pass maybe so just those few who didn't spot it, let's maybe keep it here. So basically what happens when, as I just said, when we don't pass by reference, when we pass by value, then it creates new variables. So in this case, when the new variable is created, then it has, so everything what we do with this variable inside the method, it has absolutely no relationship with the variables we create here, the variables we pass to the method. So it has no relationship. They're not related if they're passed by value, since at this point we just only pass the value which comes from this particular variable. So the value 21, it is then passed to this new variable, and then this will act as a new variable, as a separate new variable. But what will happen if we pass by reference? If we pass by reference, then we create variable here. So this is one variable, but then here we don't create new variable. So here the new variable is not created. It basically uses the same variable which is defined here. So it means that this variable physically it goes, let's say it physically goes to this method, it physically goes inside, it is passed by reference, and then this variable, it is actually this variable. So this is this variable. It comes from here, then it goes here, then it goes here. But this one, it goes here, but the method takes only the value of this variable. So in this case, you need to, and also when we talk about the reference variables, you need to separate the terms, the value and the variable. The variable is actually the place where you store the value, but the value, it is just physically the value of the corresponding it's just simply the value. So that's why here we have such result. So A goes, and here we have A is 34, then so just maybe to make it interesting, let's maybe define some here, and then return it here, just to make it not simply more understandable. So at this point we calculate sum takes the values we provide from here, so it takes the value of b, which is 21, and then again the set new variable is created. But a, it simply takes the whole variable, yeah. So it takes the whole reference to this variable, so it does not take the value, it takes the whole reference. The whole reference to the position in the memory where this value is stored, yeah. So it takes this this reference, and then it changes this this exact variable, yeah. So that's why the change is also reflected here. And for b, the change is not reflected since it is passed by value. Yeah. So this is the point. This is the point, and this is why we pass by reference. Yeah. So for example, how we can, yeah, maybe at this point, do you have the questions? So is it clear or is it not clear, or something needs to be? So we need to clarify something here.
I maybe will try to ask.
Yeah.
So basically, as I understood, or not understood, in the first line, in the first line we have A is 34 and B is 21,
Correct.
right?
Yeah. Yeah.
In control or right line, we have ref A and B is just B.
Yeah.
Yes.
Correct.
So my question is in line 12, where we have plus A is still 34 and B is still 21.
Now, as you can see from the
Not.
result, we have A is 90.
And how does it become 90?
It becomes 90 here,
Here.
because, yeah,
So
because
he sees the reference means that he sees the next how to say, next method, where this
no, it
yeah,
simply
I
means
think I understood. Yeah.
yeah. So it simply means, again, let's imagine you
Yeah.
have the box and you have the content
Yeah.
of the box. Yeah.
Right.
So in this case, we create the box. We name this
Mhm.
box A. Then we take the whole box and pass it to the method. Yeah. Then the method takes
Yeah.
this box. Then it makes the adjustments in the content of this box. It changes the content of this box. Then we actually, this content physically is then used inside
Yeah.
this method. And then again, this box is, I mean, it's actually stays the same. The content is changed, and then this box is shown here. But for B, we create, let's say, then this would be the box with the
Yeah.
content. Then the content again is placed inside, and then from here, it creates new box. So it basically takes the content out of this box B, it places it to the new variable, to the new box. Then the box is then filled with this particular content. Then we change a new box. Yeah. So here we have, let's say, a new box with the content, but the previous box, the initial box, it stays the same. So we don't take this object. We just take the content of this object, we place it to this variable, and then this new variable is then used. But the initial box, initial variable p is it stays the same.
So basically, in line 13, then B is still 21.
Yeah.
And in line 18, it's already 20. Yes?
This is different variable. I mean, sorry, in line 20.
Here, I mean, in sum A plus B,
Yeah.
it's B is already 20 or it's still 21?
No. You see, I change it here. So again, the scope is the same. I go from top to down.
Yeah.
So the scope is the same. From here, the variables, they are taken. I mean, for A, it is the variable taken, and for B, it is the value taken. So at this point, it does the sum. Then I do some changes with the variables, and then I return the sum. I calculate here. Yeah,
so it will be 90 plus 20. It's 110. Yeah. Okay.
No. It doesn't. No. It doesn't. It doesn't use. It doesn't. So you see, we have the sum here.
Yeah.
So first of all, it does the calculation, then it makes some adjustments with the variables. Yeah. So, but again, in this case, we have a separate new variable here.
B is 21.
And B is 21 here. Oh, sorry, here.
And here in the next one, it's already 20. Yeah.
I mean, these are two different. These are two different B's, but these are two same
the
A's.
Same A.
Yeah,
I think I get.
Yeah,
I get it.
Because this is the reference.
Yeah. Okay. Thank you.
Yeah, and I also remember I had a nice GIF about this. Since past reference, a moment, I will show you the GIF, and it was, I would say that was quite, yeah, this one. Let me share it. So I think this is one of the best illustrations we can. Is it? Sorry, it's not running. Let me. Okay, maybe I will basically share the. And then share the link. One moment. Okay, so you can open this link. Oh, okay, it's actually shown here. Yeah, so basically, let's say that we have the method fill cup, then we define a new cup as the variable, then inside the method we pass this cup, and when we pass it by reference, then it actually stays the same. Yes, so I mean it stays the same, and then when we fill the cup inside the method, pass it by reference, then it basically fills this cup. But when we pass that value, then it creates the copy of the previous cup and then fills only this cup. But this cup is not touched since, I mean, we only copied it. And this is the difference between pass by reference and pass by value. So do you have the questions about this? Okay, so and so how can we actually use it? How can we actually use it? So let's so that's the typical, I would say, C approach, C approach when we use pass by reference. So how can we actually deal with it? So for example, let's say that I want to have the methods add. So when we use pass by reference, then most of all we don't have any returning type. But instead, what do we have? So let's say we have some more case. We have integer a, and then we have integer b. And in this case, let's say that we add, say, b to a. Yeah. So in this case, we add b to a, and then what will happen here? Oh, sorry. Then I call the program, and I call the method add, and then I pass a, and then I pass b, and then I write, a. So at this point, what will happen? It simply adds the value of b to the variable to the value of a. Okay, it's running. So let's run again, maybe. So now it's better. So you see that I don't have any returning. I don't have any returning type, but But despite this fact, you can see that we can change the value of the variable we pass to this method. Yeah, so references are used when we have some kind of logic which does not require, where we don't need to have the returning value. So for example, when this would be one of the examples, we add something to b. Yeah, so we say that we want to add some kind of value to a. Again, the logic may be more advanced, and in that case, so just to not create create a new variable. So again, when we use the returning type, when we use the returning type, then we actually create a new variable. But let's say that we want to change both these variables. So for example, let's say that we have the method voids, let's say maybe make adjustments. Make adjustments, then I can pass both variables here. And maybe I don't know, maybe maybe let me, okay, maybe let's say that equals, now let's do some mathematical operation. For example, we return square root of a, I'm not sure. So just let's do some, oh no, hold on, that is, let's do the constant there maybe. And then the same for b. Yeah, so at that point, what happened? Yeah, so maybe let's adjust them here. Yeah, so at this point, I don't have any returning type again, but what can I achieve is that I can make the adjustments on these two variables. So I can adjust them as I want. I can create any complex logic I want. And so again, here the logic is not really complex, but it's not really complicated. But at some point it may be complicated. Need to do some verifications or something similar. Then yeah, you can create a separate method. Again, it can be reusable. You can reuse it as many times as you want, and then you can call it from somewhere and make the adjustment. So in this case, we use pass by reference. If we don't use it, without pass by reference, that would be, I would say, much more complicated. Since okay, you can use out. Yeah, we will take a look on it later. But the passing by reference will be the easiest way, since at this point we don't need to involve any returning type. Since again, as you remember, we can return only one value. Yeah, we cannot return multiple values as we want to have here. Yeah, so since here we want to adjust two variables, but we can have only one returning value. So in that case, that would be the solution to return multiple values. Again, we can also use out, but that will be different. So yeah, let's see what happens. Yeah, in this case we make the adjustments, then it takes the square root and then deals with these variables after that. Yeah, so this is the point. This is the point here. Do you have any questions? So is it clear or is it not clear? To need to explain something here. So basically, again, it uses absolutely the same variables. Yeah, these variables, they are all passed as they are together alongside with the values they have, and they are fully passed to these methods. Yeah, where they are passed by reference. Then inside these methods, we can do the adjustments with these variables, and then after the method is executed, the adjustments will be reflected on these variables, which are they then used inside this method. Yeah, so remember that the methods, the scope of the methods is different. It's different. I mean, it's separated. Yeah, we have the memory, so we call it stack memory inside each method. So it means that when the method calls, then the stack memory is used. So we define new variables inside, and then when the execution of the method is finished, then these variables are destroyed. Yeah. So for example, here we have the variable integer or int b. So this is the variable defined for this method, and then after the execution of this method, this particular variable is destroyed and it is not available anywhere for our program. Yeah. So method is called, variable is created, method we finish the execution of the method, then this variable is destroyed. It's not available anymore. Yeah, but I mean, what happens here? This variable is created. It is then passed to this method, and then it still is alive after that. Yeah, so this variable is here, then it is passed inside, then it is used here. This variable still remains the same. It is the same we declared here. Then the execution is finished. This variable is still alive. It is this one, and then it is used next. Okay. So is it clear? Do you have any questions? Okay, then maybe let's have the break, and after the break we will shortly talk about out option. Yeah. So let's then have 10 minutes break and meet at 45 past 7. Okay.
Yeah, we had. We started from the beginning to use it in homeworks always. Hello?
I hear Matt. We started to use it, I think. But you hear me, for example? Hear anyone? But we could repeat anyway a little bit.
You are quiet now, not hearing you, Arthur.
Yeah.
Okay, can you try now? Okay, I can. Yeah,
Hello?
yeah, I can hear you now. Yeah.
Yeah.
I'm so sorry. Yeah, maybe
Okay.
did you have any questions before? Maybe I just didn't hear you. Sorry, because
No, we were pretty silent anyways.
yeah,
You were asking about exceptions.
yeah,
I said our group did use exceptions pretty early on, but we would like to repeat anyways,
Okay.
just in case.
Okay, good. Yeah, our group gone through the exceptions as well, so that was also fine. And as I remember, also in the final assignments, some of you used it as well. But yeah, so yeah, then let's talk about exception handling. So as it stands from the name, basically why the exceptions may be needed. Exceptions basically are used to handle some unexpected, or maybe also at some point the exceptions can actually be expected behavior, since not like if we if we have the exception handling, then it means that we expect something to go wrong actually. On the other hand, so yeah, that means that something we expect something may not go as needed, or something, or there may be some action. There maybe some action may happen. Some action may happen. What we want to handle in a specific way, and it means that in that particular case, the program will work differently as expected. So what does it mean? It means that, let's say that we have some unexpected behavior, for example, division by 0. Yeah, so that's say the obvious one. We divide by 0. So let's say that we have again, let it be A, B, and let's create. Okay, let's assign C, for example. Why not? Let's assign C, and we want to divide by 0, for example. So result, that would be A divided by C. And then so basically get the result, we calculate this result. It's, of course, will be, of course, we cannot divide by 0. This is the obvious thing, and again, in this case, this is maybe not really unexpected, because because the compiler already knows what the value is, and actually it does not even allow us to. Oh no, actually it allows us compile, and here we have this exception. But yeah, so for example, what we can do as well, we can assign these values from console, for example. Yes, so we can use this try parse again. So yeah, let's define the variables, and then let's try parse. Okay, maybe it will confuse you. So let's write the values. Let's provide the values from console. Yeah, so let's try parse. So at this point, I want to provide integer values from console. So again, I use try parse, and then I provide the values from console. And then
not read line?
oh yeah, sorry. Yeah, thank you. Then I have this out, and then that would be A. So I try parse, and if parsing is incorrect, then I say that wait, of course, one more brackets and one more. Okay. Then I write and say that actually, one moment. Yeah, okay, maybe for this particular case, yeah, I usually prefer using try parse, but let's I try to use parse. I guess we got the exception if the value is not correct. Okay, let me write from the beginning. Yeah, I mean, I usually use try parse, but maybe in this particular case, let's use simple parse.
Maybe we could use try catch.
Yes, I mean, I'm not sure try catch. Let's see. Let me start with the example that we have the exception. Yeah, that we get the exception. Then we'll use try catch to handle the exception. This is correct. Let's first use try parse, and I guess parse will trigger. It may trigger the. I guess it triggers the exception. Again, read line. Okay, and let's get the second. Console. Yeah, and then let's return to the vision. So right one. Okay, so right now let's see how the program works. So first, let's try to check. I guess there will be the exception if oh, sorry. Okay, so let's write. Yeah. So I guess we have the exception even in this case. So it's triggered. So yes, you see that if we provide maybe again to make it maybe more clear for you, so you understand what happens in console. Let me also write the descriptive text so you can see what happens in console. Write A, then I will ask to provide the, yeah, so at this point, as you see, we get the exception. We get the exception that the parsing is not correct. So we can use try parse, as I said before, to detect this, but as another option, we can use try catch. We can use try catch, and so and then we can move on with the program. So then what does it mean? I use try, and I use catch, and I provide the exception, or I can just simply define what kind of exception I want to catch, and then I can write in console that in this case we don't know. Yeah, so that's also the point. When we use catch statement, catch block, then we provide what kind of exception we expect. So later on I'll show you that we can specify the exact exception, but if we simply say that we want to catch exception, we have this exception class, and we will discuss it later on, but as I mentioned to Michael before, all the exception classes, they are the subclasses of the exception class. And I mean, you can see here it's system exception, and it is the parent class for all the exception classes in the system. And also for the custom exception classes, we can define the system exception class. This is the parent class for all of them. And so the same as the casting, object casting, we can cast any exception to exception class. And the catch also works this way. So basically, how does it work? We go to the try block. Yeah, we start try block. In try block, we do some actions. Yeah, this is why it's called try. We try to do everything smoothly, but there may be some exception in between. So in this case, if there is the exception, then let's say it stops executing this block and it goes to catch block, and then inside catch block there will be the action triggered, which yeah, there will be the action triggered. So let's say something went wrong. Yeah, I can write the text. I can do some actions, but yeah, so I'm sure let's then do it here. So. And so I provide the text, and yeah, so you see that here's the comment written and the program execution is finished. Yeah, so you see that again, yeah, we have nothing below here, but maybe we can write at the end of the program that the execution is finished. It's finished. Too much. Yeah. So at this point, the catch statement will be triggered, and after that, basically the program goes its own way. I mean, the same way as it was defined before. Yeah. So just simply we have this try catch block. We can say that it is encapsulated in some way. So it is a little bit separated from the other parts of the code, because I mean everything what happens inside this block, it does not go outside this block normally. So okay, let's rerun it again. So there are some technical troubles. Okay. So and now we see that catch statement, catch block is triggered, and then right one block which is outside of this try catch block is also triggered, because after that the program simply goes its normal way. Yeah, so all the statements we execute after catch block, they will be executed the same way as if they would be executed without catch block. Yeah, so basically this is something similar what we can call, basically this is the branching, this is the part of the branching, and this works a little bit similar way as if statement, if else ifs work. Yeah, so since here we have if, let's say imaginary, if something happens, like if there's some exception triggered, then this catch block is then executed. Yeah, so this is the first point. We start try, we do the actions inside try block, and then if there is the exception raised, then catch block is triggered, and after that the program continues its usual execution. So is it clear at this point? Any questions? So the basics: try, do some actions inside, something wrong happens, then exception is triggered, and we go after that. So any questions about this? So far, is everything clear? Okay, so this is the first point, but let's say again, in this case, what happens, we define the flow, we define the branching, where the program should or should not go. And in this case, we define that the program should go here if any exception is occurred here. But let's say that we want to distinguish the actions in between the exceptions. So let's say that here we had parsing error, right? Yeah, by the way, we have the exception, we can define the exception, but again, that will be the topic of object-oriented programming, but all the exceptions, they are also defined as the objects. Yeah, so it means that every exception is the object itself, so it stores some information as all the other objects do. So it means that we can print out the information about this object in console. Yeah, so we can, maybe just to make it more clear, let's then write the message to console. In console. So in this case, it's simply directory, and in the pretty straightforward way, it shows what kind of error is this. Yeah, so the message shows that string was incorrect and incorrect format. Yeah, so in theory, I can comment out this section, so to not make it confusing, and it simply show the message of the exception object. Yeah, so again, exceptions, they are also the objects. Yeah, so they store the information. So yeah, you see the message taken from this particular object. So since this is the exception class, we can trigger something. Oh yeah, by the way, you can see that this message can be different because it can be different based on the exception occurred. So in this case, the parsing exception occurred, but let's say that we have other exception here. Okay. Let me run it again. So we have the case, let's divide by 0, and we will have different exception, which will have, obviously, to have different text. Yeah, different message. So again, we can skip using the variable here, but then we actually want have the object which stores the information about the exception. So to find out the information about what went wrong, we need to have the object. We need to use this exception object then. Yeah. But let's say that we want to get some different information. So let's see what kind of information we can get in addition to this message. So let's say what the method toString itself returns. Let's try again. It's just Visual Studio. It's a little bit, since I have multiple applications opened. So let's say that we want to divide by 0, and yeah, so you see that it basically prints out like if we simply print out the object itself, then it prints the stack information. Yeah? So first of all, it prints out the exception type. Okay? So it prints out that it is exception type is division by 0, and yeah, then it also prints out the text, and then it also prints out the source of this exception. So it says that it comes from this particular file, right? Let's see from here. Yeah, this is particular file, and also the line from where this exception comes from. In case you have, maybe let's maybe create another method. It's like a static. Let it be double. Division. So we have one integer, then we have another integer, and then we return the division A by B. So in this case, let's call the division method. A and B. So let's see what the stack trace will show us now. So let me provide A and let me divide by 0. And what happens now? Now it shows me the larger information. So first of all, again, it shows me what kind of exception is this to text, and then it shows the source. And here it is different. So it first shows me the line number again from where it is triggered. So this is the method, and it is line 48. Yeah? So it's line 48. It says that the issue happens here. Yeah? So you see we have this line 48. Yeah, so it means that the issue happens here. But then it also shows me the previous stack. Yeah. So again, remember we have when we call one method from another place, then this place is also is placed in the stack. So it means that it shows that it is line 48, which is called. Yeah, it says us that it is called from line 22. Yeah, which is called from this line. And here we have it. It's line 22. And it is also shown here. Yeah? So it means that exception object, yeah, but this is the object. It stores the information where this exception is coming from. Yeah, where it is triggered, where the method is called, what is the stack trace, how the stack looks like, and so it basically helps us solving the issue, right? Yeah. So okay, maybe let's run it one more time. So do we have any questions so far? Do you have any questions? Okay, hope it's clear. If not, let me know. So yeah, then at this point I specified that I will catch all the possible exceptions, but let's say that I don't want to catch all the possible exceptions. I want to catch only those exceptions I expect, right? So maybe I don't expect that at this point, let's say that I only expect that I can divide by 0. I don't expect that there will be the parsing error. So what I can do, I can specify that I only wait for this particular exception. So maybe maybe first of all, let's then no. Let me then just to show you. I guess I didn't show you. Let me show you now. Exception. So in this case, this will catch any exception. Yes, I said just let's try again so we can say it. So it, as you just seen, it can catch division by 0, and it can also catch parsing error. So let's say it has something like this, and it will show me the message, and it will show me the stack trace from where the issue comes from. Yeah, so you can see that it's the stack trace is larger. You can see that the source is main program. It is line 19. So this line, then it goes deeper. It goes to the parse method. Then it actually is. It is the class int32, and then the parse method is, and then it goes deeper, and at some point it throws this particular exception. So yeah, then let's say I don't wait for the hold on. Let's say that I don't wait for this for the parsing error, parsing exception. I only wait for division by 0. Let's say I do it this way. And then what happens? Then division by 0 will be handled the same way as it was handled before. Let's try again. So in this case, division by 0 will be handled the same way. So it is shown here, and it is the same. But what will happen if I will trigger the parsing error? In this case, the parsing error will not be handled. So here I provide that I only catch divide by 0 exception. Yeah. So and I don't catch any other exception. Right. So on the other hand, what can I do? So the opposite would be that if I catch what's it? So what was the type of the 6? Oh, sorry, a moment. Let's try again. So I can see what is the exception type for the parsing error. Write some text, and I see, yeah. So I see if that's format exception. So here you can see the name of the exception. So then instead of division by 0 exception, I can use this format exception, and then what will happen now? What will happen now? I can trigger the incorrect format exception, and then incorrect format exception will be handled here, right? I mean, the parsing exception will be handled here. And so let's then try to divide by 0. On the other hand, division by 0 will not be handled here. Yeah, so it will be skipped. So then, yeah, so I guess at that point, I hope it's clear for you that we can specify what kind of exception we expect. On the other hand, let's say that we want to, let's say I only want to catch in this particular statement, I want to catch, so in this particular catch block, I want to catch format exception and division by 0 exception. How can I handle this? I would say that can be done quite simple. I define that I catch all the possible exceptions here, but then I can actually check. I can actually check what is the type of what is the type of E what is the type of E? So I can check if the type is division by 0 or E is this, what was it? Text type of, sorry, what was the type of this exception? Format exception. It's here, format exception, and then it will trigger the code below. Otherwise, so basically, as I teach you last time, so in this case, I can use this if statement and then put the whole code inside this if statement. Yeah. On the other hand, yeah, so you can see that I put this large else statement inside the box. So the opposite way to not have such large statement, I can do it not, and then I can simply check what will happen otherwise. And otherwise, I want to pass this exception further. Yeah, I don't, inside this catch, I don't want to handle other exceptions. So if so, then I can use throw, and I can pass this exception further. Yeah, it changes stack information, but no, hold on. One moment. One moment. Okay, and in this case, it will. Oh no, simply. Then yeah, so then we can simply throw. Okay, that would be correct now. Yeah, so basically let's then check. I guess at this point we can't get any other exceptions. Yeah, so this exception will be handled, and also exception by format exception will also be handled. I heard there are some questions coming in, so you can ask. Not any questions? No? Yeah, so basically throw means that it will basically pass this exception further. So basically it goes here, so we have catch, it catches the exception E, and then what basically I check if E is division by 0 or E is format exception. Then if it is not, then I simply pass this exception to other catch. Yeah, so which is not provided here. Yeah, so that would be the option how to handle multiple exceptions. So it means that other exceptions will not be covered here. On the other hand, we can also use multiple catch blocks. So let's say that I catch division by 0 here, and let's say that I have another catch block which will then catch the format exception. Let's say M. Then I can write, I can basically do some stuff here. Right, one. Here we have the format exception. Okay. And yeah, like I said, maybe let's keep using key since I don't need it here. And then you'll see that different catch blocks will now be triggered for different exceptions. So if I divide by 0, then this particular exception, this particular catch block will be triggered. On the other hand, when I run when I have the format exception, then this catch block is triggered. So, do you have any questions?
I have a very small question.
Yeah.
I wanted to ask if in this try catch statements, like catch never leaves with try, like try is compulsory, and then we can use several catches or no? Can you comment?
You mean this way? We can use several catches if you. I mean, if you.
Yeah. The question was that simple, and but the catch one is never one. Always need is in pair with try. Yes.
Yeah. That's obviously
Okay.
that's obvious that try needs to. Yeah, if you want to have some, like if you want to have the exception handled, then you need to use try. Yeah. We cannot use catch without try.
But these several catch what we have here, they are catching something
From here.
like in which this part, right?
Yeah. They are not catching other parts. So, for example, if you want to, like, if you have the exception here, so like this catch is triggered. Yeah, that's also a nice question. Then let's say that I want to. So this division by 0 exception. Maybe let's make it more interesting. Let's then change them, exchange them, and let's say that I want to. In this case, let's maybe do it in such a crazy way. Then let's say that I want to divide A by B. Let's define the result here. Show results. And then let me assign the result here. So that's a nice question. So you can understand how the scope is going. So let's say that we provide A, then we have this format exception. So we have format exception, the program goes here, and here we have another exception, divide by 0. But this catch is not triggered from here. So that's the point. Everything what we try catch, it is stored under this block. So every other catch what is stored under, let's say, catch or outside this try block, it is not covered by these catches here. So it is called here, but you see that it is not under try section. It means that this catch will not be applied to this particular exception. What is triggered from here? And this works separately. It is not catch. Like if we reached one of the catch statements, then other catch statements will not be reached. And so they will be ignored. Same as we have ifs, if, else if, and so on. If one of the ifs is reached, like we have it here, then other else ifs and else blocks will not be triggered. Same as here. If one exception is triggered, then other exceptions will not be checked. So this is the point, yeah. So this is the point. If you want to handle something inside catch, then you need to write another try catch inside. Yeah, so like if you want to handle try catch here, then you need to use another try catch.
Thank you, it's clear.
Yeah. Or you can use the global try catch. So for example, you can also, as I said, you can have try catch inside try catch. So for example, that would be that you use try catch inside try catch. And so you can use try catch inside try catch, and you need to have catch obviously. Then let's say that you have exception here, and then you can write this exception here. So in this case, this particular case right here, we are still located inside this try. Yes, so see where the outer try starts and where the outer try ends. You see that everything what we have inside, it is still located under this, let's say, huge try block, right? So, and then we can run the program. Okay, I had build errors. Where are these errors? Oh yeah, to define as e variable. Yeah. So see that now this particular exception comes from here, but it is then catched. It is called then here. So this is the outer try catch, and so then everything what is inside, everything can be called by this catch. Yeah, so that would be one option, and then there is another option. Another property, I would say, not option, but the property is, so let me comment out this try block then. There is one more point that the scope, I'm not saying the scope, but the executions, the sequence of catching, it basically comes from, again, it goes from top to down. Yeah, so the same as in if, else, ifs, and else. At first we check, like we have the exception. So exception is thrown, yeah, so the exception is raised, and then it searches, like if we are this flow, it happens from the program perspective. Program goes inside try block, it executes the statement one by one, and then at some point we may get the exception. So it gets the exception, it checks the type of the exception. Then it first we checks, is it located inside try block? Again, we can be inside the method. It doesn't matter, like in this case we see that we have division by 0, but division comes from the method. Yeah, so again, from this perspective, we can put any method, we can encapsulate it, and it still is the part of this try block then. So the program checks if we are inside try block. Are we inside try block? It's true. Then it checks for catch statement. So let's say that there is the exception triggered, and then exception has its specific type as all the object have. So it goes to the first catch. Remember for the ifs, yeah. So first we start with the first if, and we check if condition is true. So here it checks if the exception is format, if the type of this exception is format exception. So is it true? If it's true, then this catch block is triggered and no other checks are done. So if it's false, then it goes to the next catch statement. So then it checks if the exception has the type divide by 0 exception. Is it true? Excuse me. Yeah. Yes. If it's true, then this particular catch statement is triggered then. Else it will stop the program. Yeah, as you've seen it before. Like if none of these exceptions is here. But it's simply, the idea is that it goes from top to down. So for example, we can have, let's say, the third case when we catch the exception in general. So in this case, it is possible, and basically, so we can say that this exception handles everything. Yeah, so I can say that this particular exception handles everything. And yeah, so basically here you may see one interesting point. Actually, the format exception and divide by 0 exception, they both are the subclasses of exception. So it means that exception it can catch both of them, right? It can catch format exception, it can catch division by 0 exception, it can catch any possible exception what we have. And yeah, so but you see that it is not incorrect. Basically, this is what I said. We can consider this as else statement. Yeah, so we have if, we have else if, and we have else. Yeah, so if exception is format exception, then this block is called. If this block will be triggered. If exception is divide by 0 exception, then this block is triggered. Else, like if any other exception can, then this block is triggered. Yeah, so it will simply go one by one and check if the particular block, if the particular exception is raised. But then the question, now I have the question to you. Can I switch these two catch blocks? So can I put exception here and format exception here? So can I swap them?
No,
Yes, that's correct. And why?
because it's the last should catch everything else.
That's, yeah, I mean, the idea is, yeah, this is
Additionally, sorry, I have a tiny question additionally
yeah.
about the syntax. So there, I know that there's differences in this writing in this braces near the catch. As you say, this format exception with letter E.
Yeah.
There can be with letter EX and without anything.
I mean, this is, yeah, this could, I mean, we actually define the name of the variable here. So we can define it as we want. So I can easily say that that would be my variable or something like that.
Ah, okay. Because I have seen only this E and not EX, and so
I mean,
what is it?
Yeah, actually, I guess, yeah, because in different languages, yeah.
So this can be nothing there.
Yeah, yes,
variable.
I mean, we can type anything we want here. This is the name of the variable. Yeah, this is why. But yeah, so this can be X if you want. We can name it X. This is just simple name of the variable.
Okay, thank you.
Yeah, yeah. So this is the name of the variable. So but yes, I guess yeah, actually I'm mixing in between the languages, and that's why, yeah, in C# it's mostly X. I use E because I recently used it in PHP, and yeah, but yeah, of course, this is the name of the variable, so it can have any name we want. Yeah. So yeah, this is true. This
And
is
it's possible to not use any variable as well, like
yeah.
divide
So yeah, so
zero
we can
and
see here.
nothing.
Yeah.
Yeah.
The variable is needed just to if you want to take out some information about this particular exception. Again, the stack trace, the line of code where the issue happens. Again, if we want to investigate on the particular issue, then that would be quite useful
It's
for us.
from the system, this information.
Yes, yeah, this information comes from
Okay.
the system, and actually, in addition, we can define our custom exceptions. Yeah, so that would be actually more about object-oriented programming. But so maybe just as the last part of today's session, maybe let's define our custom exception. Why not? So that will be custom exception class. Then basically says that we want to extend it. We want to extend the exception clause. So then I can simply use this my exception custom exception class. Okay, maybe at this point I will not define more details, but yeah, this is actually your question was from where the data comes to these objects, and actually, yeah, the data comes from the system. But like if we have the custom exception clauses, we can define our own data there. Maybe I will talk more about it when we go through the object-oriented programming topic. But yeah, we may have the custom exception as well, and we may fill out. We can define the logic, and we can fill some information here. So, for example, so yeah, maybe just a simple example. I can define the constructor of this. Exception. I can define the constructor. Public custom exception. So I need to go. Oh no, that's fine. So and here I can, let's say that I define just simple. I think I defined say the string, which will be the part of the object, and then it will be, let's say, my text. Then I can pass this my text to the custom exception. So let's say to be my text. Then I can assign this text to the element of the object we have, and then I can override the methods to string. Be public string to string, and then I will return, let's say, my current text. Yeah, I need to use override keyword. Okay. Um, not run. Okay. Then we later. But yeah, so what's the point? The point here is that that we can throw this. That we can call this. Sorry. Let's write override here. It should be fine. Yeah, we can catch this. We can throw this custom exception. So basically, we can manage the flow of the program, because when the division happens, division is actually a system operation. So the system simply checks if we divide by 0. So if the value we divide by is 0, then the exception is thrown. Yeah, so it's done technically inside. For the parsing, it is the part of the code. Yeah, so maybe let's check the parsing error once again. Yeah, so you see that the parsing error, it is actually a system exception, but it actually is thrown. I'm not sure if we can navigate to this code. Let's maybe try. Let me maybe quickly try to navigate in this code. I'm not sure if it's possible. It will allow me, but let's do. So we go to parse method. Okay. No, it's okay. It's okay. Okay, it does not allow me. Yeah, okay, then never mind. Yeah, so basically, but there is the code which then has this the part which the logic which actually throws this exception. And then we can actually throw exception by ourselves. So then yeah, maybe I can write some conditions here. So maybe let's say that if a equals 3, then let's throw our exception. Let it be custom exception, and let's say I don't want to deal with the value 5, yeah, so or something like that. Wait, so the value 3. So what will happen at this point? This exception will be triggered, right? And yeah, so maybe just before we print anything, let's just simply see that this particular exception will be handled. Yeah, so basically using throw, then we create new object, then we create new object, exception object, then we provide the type of the exception to be created. Okay, so then let's say that will be the value 3. Then you see that it checks it value 3. Then it basically catches this particular exception. Yeah. So and let's say that we want to. We can also print out the information the same way as you see we printed it here. Then we can also print out it here as well. And basically what will happen here it will print the information about our object. So let's see that we have 3. And so we see here we have the information. So this is answering your question, not the question, but what you said, that the values, the information is taken from the system. So yeah, it's true, but like if we have custom exceptions and also the other exceptions, they may have some specific properties since they are the classes. So again, we'll talk about the object-oriented programming a little bit later, but the classes, they have their own attributes, their own methods, their own parameters, their own specifications. So every class has its own specifications. The same as for the exceptions. The exceptions may have some parameters, some specific parameters, so there can be different, and then we can also provide different definition for them. So if we have custom exception, in this case, I have the constructor. Yeah, the constructor takes the value and the text value, and then this text value is assigned to the variable located inside the object, inside the class, inside the object. And then I use toString to describe my object. So yeah, I can use some custom definitions, and then of course the system part will be then, the system part will also be written. Yeah, so for example, I can run the super class, or maybe let's not do it now. But yeah, so this is how it can be done. Okay, do you have any questions?
Yes, I have a
Yeah.
question, but question is very simple again. And I was just looking to all this code, and my attention grabbed this how to say, I forgot in English. Two not plus, not minus, but equal signs. And I
Oh,
think you actually explained in a theory class this, but I
yeah,
still don't understand. Like for example, int a is one
yeah,
time equal sign, a
yeah,
is 2 time equal sign, and in theory you said that if there is comparison, there is 2 equal signs, and if it's an
yeah.
assignment, it's 1. But still, maybe you can talk
That's
a little bit more.
no, yeah,
Yeah.
that's the operation. That's the operation which returns the result. So you see, this is the operation which assigns the value from the right side to the variable on the left side. So this is the assigning operation. We call it assigning operation. So please take the value from right side and assign it to the variable on the left side. When we have comparison, it takes like it's similar as we have the methods, we have the functions, which return us some results. So here we have the operation which takes 2 arguments, yeah, the value on the left side and the value on the right side. So the values are taken, 2 arguments are taken, and then this operation checks if the value on the right side is the same as the value on the left side. And then, like the operation is executed, the check is done, then this check returns true or false. Yes, so if the comparison is like if the values are the same, then this particular comparison operation returns true. If the values are different, then the operation returns false. Yeah, so this is the operation which, oh yeah, actually you can see the description here. Yeah, bold int operation. It actually that's the function. That's the function. Yeah, that's the function which defines the operator. And actually, there is also the possibility to overwrite these operators. We'll maybe not do them, but yeah. So this is the operation which returns true or false. This is.
But that's
yeah.
sorry.
No,
Continue.
continue.
No, I just checked also for examples that I think there was a line in code C is A plus B, and it still is only assignment. But I'm not sure.
Yeah.
Maybe you deleted it, but it's also one this one equal sign.
Yeah,
but maybe it was somewhere.
But I haven't compared previously. I haven't. I
A
did.
plus B.
Yeah, but that's the. Yeah. I guess I remember what you're talking about. Yeah, this one. So this basically means the same as this.
Yeah, exactly.
Yeah, so that's why, yeah, it's just the shorter way. It's just a shorter way of writing this, but yeah, so this is the same as this one.
Okay.
And basically, I can do this operation for, like, I can select any possible operation I like. I can use plus, which means A plus B. I can use division, which means A divided by B. I can use modulo, which means A modulo B, and so on. Yeah, so this is just the shorter way I write.
But if you use 2 times equal, it will show an error?
No, it will. Yeah, basically it shows an error because it basically returns the value to nowhere. Yeah, if I say that this would be result or something like that, that will be correct. That will be correct since this is the operation which returns true or false. So we take these two and get the result, true or false. Yeah, so because here, if I use comparison on it, basically it returns, yeah, it returns the results, true or false, but it returns it to nowhere. Yeah, so that would be like if you simply say 4 plus 5, you just simply have the result 9, but you return it nowhere. Yeah, the same as here. It takes the values from A and B and compares them and returns true or false. In this case, I return it like actually to nowhere, and that's why it shows me the error.
Okay, thank you.
Yeah. Yeah, that's a good question. But yeah, so in this case, equal like comparison operation is not related to the assignment operations. And actually this may be confusing, especially at the beginning. But yeah, this is what you should understand, that normally, like in some programming languages, actually the the assignment operator and the comparison operators there are the same. For example, in Visual Basic, they are the same. And maybe if you look at Visual Basic, the comparison operator and the assignment operator, they both are like single equal sign. Yeah, but normally, like yeah, there are also a few more languages where this operator is the same, but mostly these are two different operators, and I totally agree with this approach, since it makes sense. Like we have the operator equals, which simply assigns the values from right to the variables on the left. So this is assignment operation, yeah, the assignment function. And then if we compare two values, then there should be another operator used, right? And then this operator is defined by double equals sign. Then. Okay, any more questions? So if there's anything not clear, okay, then so have you started the practical assignment? So do you have any questions about it? Okay, no. Then you can let me know. And then yeah, so then I also written that as an additional assignment, that would be activity free. So also until the end of the week, you can take a look on this and also complete it. Yeah, that's an optional one, but it uses the collections, yeah, the QA collections, quite useful, and then you can work with QA collection types. Yeah, so you can take a look. This is the activity free. So one moment, let me quickly open it so I can check the real name of it. So yeah. Sorry, yeah, this is type 7. So I shared it in chat now. So that in chat. Yeah, so that would be the optional one. You can take a look on it and try to complete. Then yeah, so yeah, do you have any questions?
I have a question regarding the test on Monday. I wanted to make sure it will be more like theoretical, I don't know, multiple choice.
Yes,
Okay.
that will be theoretical test with multiple choices, yeah.
Thank you.
Yeah, and the idea would be that I guess I will give you somewhere at the middle of the session, and then you can submit it until the end of the day. Yeah, something like that. Okay. So, do you have any more questions?
I have one comment
Yeah.
regarding our group. On the list is Agnes Brieda, but she will actually won't attend. So it was some kind of miscommunication between Accenture and her. She wasn't going to attend. Yeah.
Okay, then thanks. I
Yeah.
will remove her. Okay. Thank you. Good. Good. Okay. Anything else from anyone? Okay, then I will. Yeah, you can check the code in GitHub repository. I will then share it. I will then share it with you. So let me then share, and then yeah, then the plan for tomorrow is that we will start object-oriented programming. So a large topic and really important to understand. So I hope you, with the group which did not work with me before, so you already had some tasks and some theory about object-oriented programming, but yeah, tomorrow we will start repeating it. Yeah, so we'll go through some key points there and hope it will be clear for everyone. Okay, so then thank you very much for your attention today. Please continue working on your on the practical assignment for this week, and then meet you all tomorrow. Thank you, and meet you all tomorrow.
Thank you. Goodbye.
Thank you.
Bye.
Bye bye.
Bye.
Thank you. Bye bye.